Now, no matter how you are good in the art or the skill of titration, if you don't know the calculation aspect of it, you are not going to get it right. The titration will give you the titer value, which is your end point. You will need that to calculate the concentration of the unknown. Now, at any time in titration, you have two solutions. One is the alkaline solution, which is your base, and the acidic solution. In our titration, we use H2SO4 as our acid and then NaOH as our base, which is sodium hydroxide. Now, you need, after getting your values from the titration, our values, let me have a table. In titration experiments, this is our titration data. Now we have our first reading, we have our first reading and the second reading. Now the rough is just a trial titration, so it's not included in the calculation of average titer volume. So we're going to use the first and the second titration for our titer volume calculation. Now, this is our initial readings in milliliters. This is our final reading. Now, subtracting this from this will give us the volume of acid used. Then the same thing is done here, subtracting the initial from the final reading will give us the volume of acid used for the first titration, the same thing for second titration. We can now go ahead to work the average volume of acid used. The first titer volume was 12.50, the second one was 12.52. By average, these two values ought to be added and divided by 2, and then the average gives us 12.50. Now this is due to how skillful I am in the act of titration. Sometimes the values can slightly vary, but whatever it is, the variation must not be too much, so that while doing the average, we're able to get the correct value as the average value. Now, we have the average volume of acid used. The next thing we're expected to do, we have a common formula. Having the table set, you need this formula for calculation of the unknown concentration. Now, earlier we said that two solutions are required: alkaline solution, which is base, and acid solution. Now, one of them are usually standard solution, while the other one is unknown solution. When we mean standard solution in chemistry, we mean a solution with known concentration. Now, in this formula, CAVB equals to A over B. Now, A is molar concentration of acid, B is molar concentration, CB is molar concentration of base, then VA is volume of acid, which is your titer volume, the value gotten by the average work. Then VB is volume of base used, which is the volume of the base used 25 with this intensity, which is, in this case, VB is volume of base used, equals to 25 ml. Now, the volume of acid used, what is it? Your average total volume is 12.50. Now, the mole ratio of the acid and the mole ratio of the base, which is A and B, is gotten from a balanced chemical equation of the two reactants. H2SO4 aqueous solution plus sodium hydroxide aqueous solution that give a product of Na2SO4 plus water. And also remember that always acid-base titrations, the products are always salt and water. This is salt. So as a result, salt is always solid, while this is liquid. Now, this is the representation. Once you look at it, what is required is balanced chemical equation. You are required to balance this chemical equation. How do we balance it? Check here, how many hydrogen do we have at the left hand side, and how many hydrogen do we have at the right hand side? This is our left hand side, this is our right hand side, by your view. Now, we have two hydrogen here, plus one hydrogen here. Here we have three hydrogen. Then when you come to this side, we just have two hydrogen. So what do we do to balance it out? Now, let's increase this one. Here is 3, here is just 2. Let's increase this one. Now, it means this is now 4 hydrogen. Now, we come here, what do we do? Here we have just 3 hydrogen. What do we do to increase the number of hydrogens here? We add 2 here. Now, we have these 2 affect everything here. So here is 2 hydrogen, here is 2 hydrogen, it's now 4 hydrogen. Here we have this times this is our SO4. We have just one SO4 here, then here let's look at SO4, or let's go by X. How many X do we have here? We just have one X here, and then one X, which is sulfur. Now, our X is balanced. We go for oxygen. We have 4 oxygen here, then 2 oxygen here. Here we have 6 oxygen at my left hand side. Then here is 6 oxygen. Let's look at it here. Here we have 4 oxygen. 4 oxygen here, and then we have 2 here. 6 oxygen. Our oxygen is also balanced. Then what is remaining? We come to sodium. Our Na. Our Na is 2 here. Then we come here is 2. It's also balanced. Then what else have we not considered? Then at this point, our equation is perfectly balanced. Now, you discover that the mole ratio, we have 1 mole of hydrogen, 1 mole of H2SO4 reacts with 2 mole of sodium hydroxide to give 1 mole of Na2SO4 salts, then 2 moles of water. Now from this, you now understand that the mole ratio, our A will be 1, while our B should be 2. So in respect, this is mole ratio of the acid, which should be 1, and this mole ratio of the base, which should be 2. Before this time, I said one of the concentration is known in the acid-base titration. Either the concentration of the acid is known or the concentration of the base is known. But in the titration we just carried out, the concentration of the base is the unknown, while the concentration of the acid is 0.1 molar. that our acid solution was the standard solution, which is with a known concentration. So Cb, which is the concentration of the base, is unknown. Va is our title volume, average title volume. Vb is the volume of the pipette, the base we measured, 2500 ml. Then A is the mole ratio of the acid. B is the mole ratio of the base. Now, it means that what we are looking for is Cb, which is the concentration of the base. From this formula, you can make Cb the subject of the formula. Now let's go. Being that Cb is the unknown, the concentration of the base we are looking for, we make Cb the subject of the formula. Now, this is making Cb the subject of the formula. When you make Cb the subject of the formula, you have Cb equals to this. Now, our values, our Ca, you make substitution of the values. Ca is 0.1 molar, Va is 12.50 ml, then our mole ratio of the base is 2. Then our volume of the base 2500 ml. Then the mole ratio of the acid, which is A, is 1. Now, the like units cancel out, and then when you do the multiplication, you have this, and then you have 2.50 molar over 25.00. When you do the division, it will give you 0.1 molar. So this is the concentration of the base. So when able to solve the problem, this will now be 0.1 molar. This is how to calculate the concentration of the unknown. The case some other time can be that the unknown is the acid. What you have to do is, after your titration, you just use this formula and change your subjects formula by making Ca the subject of the formula, and then doing substitution of the various values from your data table. You'll be able to arrive at the concentration of the unknown. Thank you very much.